Next, 2.2. Then it says use the parallelogram of forces method to determine the equilibrant of the two forces in the diagram below in magnitude and direction. So this is where our answer lies. And then I'll make it also with another part of a marker to say we need to find number 1 magnitude and number 2 direction. And they said we need to what? To use the parallelogram forces, meaning we need to draw an accurate sketch, 60 newtons and 40 newtons. So whenever you do this, I'll try to sketch this with you. I haven't done much before, but I'll try to sketch it. Listen, you come up with a scale. Now I'm gonna be a bit slow because I'm not used to this, but that's the thing. Come up with a scale. For example, you can say 1 centimeter is equal to what? 1 centimeter is equal to 10 newtons, you know. So they gave us 2 now. They gave us 60 newtons, right? And then what do you think will be 60 newtons? It means 6 centimeters here. If we look at our scale now, 6 centimeters is equal to 60 newtons. And what else? We also have 4 centimeters is equal to 40 newtons, because it was 40 newtons. You see, you just divide by 10. Where there is 60, it's 6. Where there is 40, it's 4. Why? Because 1 centimeter is 10 newtons. I explained that you need to come up with a scale before you can draw anything. Then from there, let's try to look at the diagram. They have this 60 facing to the, remember your cardinal. If I can also look at your cardinal point, you kind of have something like this. If I can remind you your cardinal points, it's like this, it's like this. So you have this, you have that, you have that, and then you have that. So what do you have? You have this as my north, my south, my east, and my what? My west. Alright, these are my directions. So now if I'm to plot this thing, or to draw a sketch of this thing, you can see that there is the 60 newtons more like facing the west. So that's where I'm going to start from. So with it, I'm going to have something. Let's draw this thing now. Let me have my drawing instruments here, and then take my applications. I'll need a ruler and I'll need a protractor. So this is what I need in here. Alright, so as I said, I'll be moving in and out and everything. So let's start with here. Remember I need 6 what? Let's start here, 6 centimeters. So in my ruler, I'm gonna measure. Let me mark it like this, and let me mark it like this. It's good to mark it. So that is what I'm having. That is my what? My 6 centimeters. And then don't forget, I'm moving in this direction now. Let me have my arrow. It's in this direction. Alright, then you can write this as what? Your 60 newtons. Right, that is the scale I'm having. Now, it says here, there is an angle of what? 135. You see this angle? So I can now use my protractor for that angle of 135. So what I can do, what happened to that protractor of mine? Did it disappear? Okay, let me check it again. Sorry about that. There it is. Okay, so I need now my protractor here. I need now to measure what? 135. So I'm going to rotate it. You have to get used to this, guys. With your protractor, place it horizontally there, and then what you have, remember you need 100 and what? 135, like this. So you're counting on the outside scale to say the outside scale here, this is my 10, my 20. See, I'm going this direction, facing that, and I need 135, and it's somewhere here. There is 135. So what I can do, I can start from here and say, if I can have my mark like this, it's 135 there. Are you seeing that? Or I can even do it like this. Start from here, try to locate my 135. There it is, and make it long as possible. There. Remember, this is just a sketch. Then from here, what I need to do, take it out. I need to bring my ruler now. Okay, let me mark it here to say this was 135. It's 135 degrees. Then I bring my ruler. When I'm bringing my ruler, the purpose of the ruler here, let me make it small like this. The purpose of the ruler here is to measure. Remember, it was what? It was 4 centimeters. So I want to measure 4 centimeters now. So if I rotate my ruler, okay, like this, rotate it a little bit, yeah, right. Let me see if ever it can. It's not as bad. Remember, this is gonna be an estimate. Let's rotate it a little bit again. There we go. So I'm measuring what? 4 centimeters. There is my 4 centimeters. Okay, not as what I wanted, but like this. This is my 4. Okay, so now I can take off this ruler away, and then I can come here and mark it and say it was like this, my 4 centimeters. All right, so when I've done, then I measure this as my 40 newtons. All right, now when they say parallelogram, I can even use this ruler of mine. You see, mine, I'm able to even come here and draw it exactly like that. But for your sake, I'll say let's look for the protractor again, and you can even have a protractor to say, if you are going to use a protractor here, what you're going to ask yourself is, okay, with the protractor, how do I then draw this? With the protractor, you must always understand that if, for example, this is 135, you take a calculator and you subtract from 180. So you say 180 minus what? 135 equal to 45. So you're going to take your protractor here and you measure 45, but let's rotate it again like this, and I need to bring it here, and as I'm saying, it's rotating it as nicely as you can. And remember, you need to measure 45. I'm using the inner scale now. I'm going to use the inside scale, and in the inside scale, remember, I'm looking for what? For 45. So I'm gonna take from here, and my 45 is there. See that? That's my 45. I can make as long as it is, that line. But now, this is what I'm trying to say to you. If you are using the ruler, if I bring in my ruler, do you see that without changing, that line matches? Look at that. Do you see that? And then, what must I measure? I need to measure also 4 here. I need to measure 4. So what I do, I take that line like this and measure 4. See? Remember, that then becomes parallel. Look at the arrow now, what I'm going to have. That's why they call it the parallelogram. There is the arrow, and this one, I'm going to call it the 40 newtons, because it is parallel to this other 40. Are you seeing that? And then again, I'm going to take my ruler and join these 2 points now. Take the ruler and then twist it around and join these 2 arrows here. Join them together. See here. If you join them, look at this. If I measure it, it must be 6. Do you see that? It mustn't be far from 6, but you can see that it's actually matching 6. So I can join the ruler there and have this one being, okay, it's a bit down, but it's almost there. Let me take it a bit up. Not that up, but this up. Alright, so let's make that and see if it gives me that. There is the 6. This one is much thicker, but I don't know why it's changing. Sometimes thick, sometimes not thick. So look at it. Now, where is it going? It's very important to look at the arrows. Where is it going? It is going, remember, it is going this direction. So now let me look at the direction I'm going to use. I'm going to use my purple and make it thick. So I'm going to take the 60. After the 60, I'm going to take this one, the 40. Look at the arrow. Now we call this the parallelogram. Why? Because it's a complete two parallel lines opposite to each other. It's a pair of parallel lines. But now if I use the one that I showed you on the arrows, look at this. I start there and I go there. We call this the head to tail or the tail to head method. Meaning here I've got my tail of the parallelogram and here I've got the head. Then you join these 2 points together. That's where the whole thing is about. You join them. I'll use a white line to join them together. When you join them together, we call, if I put an arrow there, that line that is joined, maybe it's better to make it thick. This line here, we call it the equilibrium. You see? That's my equilibrium here. Okay, so equilibrium. Alright. In other words, it's more like my resultant. Okay, actually I will use not the equilibrium, it's my resultant. Let me use the word resultant. So that resultant, let me change here. It's not the equilibrium, it's the resultant. It's the resultant of the what? Of these two forces. Then if I draw a line opposite to it, I'll make it red. If I draw a line, take your ruler, bring my ruler back. I don't know why it's escaping like that and changing the. If I take my ruler like this, see this? And then I draw a similar line opposite in direction. This line here, it must be opposite, but I'm going to measure it so that it makes sense. Let me undo. I think, okay, I see now. Let me make it small. There is that line. I'm going to measure that line with a ruler. So what is this other line? This line is from 0. Let's make this bigger so that we can try to draw this. And then let's measure it. You see, it's escaping me there. Come on. This is somewhere like 4 point. Look at it. You can see it's like 4.2. You see? Because it is more like if I use my red pen, it's more like here. See? You see? It's more like 4.12. That's 4.2. So it's a resultant. Let me write it down. A resultant is equal to 4.2. So if I will use that, I'll come here and also say, what about my I measure another 4.2 here. See? 4 point here, that is a 4.2 here. Somewhere there. Now I can come here and do this now. Take it off. That's my 4.2. Now guys, I need to erase some stuff. This is my equilibrant. Now the equilibrant, you need to know it faces this direction. And what we call this one? We call this the equilibrant. Equilibrant. And then with that, remember what is the equilibrant? It's 4.2 centimeters. But now when you're converting, go back to your scale. What was the scale? 1 centimeter to 10 newtons. So 6 becomes 60. So 4.2 becomes what? 42 newtons. You see? Then this is 42 newtons. And even here, this is 42 newtons, the resultant. Are you with me? So if we come back to the question, what does the question says? Use the parallelogram to determine the to determine the equilibrant of the two forces, not the resultant, but they wanted the equilibrant in the diagram below in magnitude and direction. So we got the magnitude. So you can now conclude and say, therefore equilibrant, let's write this, equilibrant is equal to 42 newtons. We have done that, but they need the what? They need the direction, guys. They need the direction. What the question is, what will be the direction of this? Then you've got two ways of finding the direction. You can take actually a straight line here. I'll make it white this time, small, just a small line, straight line like this. All right. In essence, I wanted it to be okay. Let me take it like this. I'll show you what I'll do. This line, and then after that I move it because it's already straight like this. And then this dotted line, I'm gonna make it like this. It's a dotted line to me. And we call this the what, guys? We call this the horizontal line. Horizontal line. So we can measure using the horizontal line. This part is called above. Here down is called below the horizontal line. You can use that. So we're going to measure this distance here. I mean this angle, not the distance. So whatever we are measuring, this angle is going to be above the horizontal line. So what you do again, I don't know why my protractor keeps escaping me. So we do that, we take this protractor, we bring it there. Let me take it. See, it's just that I expanded this thing. So we take this protractor, bring it there, and then we measure to say, what is this? You know. So I need maybe to also draw a line to say it will start from here. That line, if you continue with it there. Do you see where it takes us? I'm gonna remove it. You can see that I'm moving from I'm measuring from here. There is 10, 20, 30, 41. You can say 41 there. So this distance, you can see that it becomes 41 degrees. Can be 41.15. So it's 41 degrees. So what are you gonna say when you're writing your answer? You are going to say equilibrant is 42 degrees, and then direction is equal to 41 degrees above horizontal line. They allow that. See that? Or you can use this part that I did. Remember when I started, I used this part which says north, south, east, west. Let me pull this far away. This north, south, east, west thing. So you can see that if I use south as my reference, I can come here. Okay, let's use this one. I can say this, then here is more like my east. When I'm going this direction, I'm going towards my south, my north. So I can use that and say, you can write it as what? East 41 degrees. From east you move 41 degrees towards north. They allow that. Or you can have these are different ways. This is another option. Or you can say, all right, what if I have a straight line like my north? You see, you don't have to be accurate as such. If this was your north, say this was your north here. So you need to ask yourself, what is this distance? Remember, you separate from 180. So what you do, you say 180 minus what? I mean, not 180, it's 90 minus 41, because that is the right angle. So you see, it becomes 49. So this is 49 degrees. So your direction can be north 49 degrees towards east, you see. So it can be north 49 degrees on your way to east. Are you with me? That is how you can bring these answers. But now, how do you present your final answer? To present your final answer, guys, you don't need to show many of these things that were being shown here. So let's take this now off, because it was just running away from me. So now I don't want it now. Let's take this off. Now look, you need to be erasing unnecessary stuff here, because they don't need to see this. They don't need to see this, you know. And then this, we don't want to see this. It was me trying to explain, but that small dotted line is still good. And then even here, this one, you don't need to see this. Okay, let me do this. This one is not difficult to delete. You just do this. I don't need that. And then even here, this line, I don't need it. So you see, let me make this small again. I don't need this. So this is my parallelogram forces that I needed. This is the triangle I need. What do they want to see? They want to see the 40 Newton, 40 Newton. Even here, I forgot. They want to see the 60 Newtons here. And remember the arrow, they want to see that arrow there to say it's going that direction. And yeah, these arrows are like that. They will give you a mark. Labeling this, labeling this, labeling this, labeling this, labeling this, and labeling this. We can actually take away this thing here, because it doesn't save. Alright, so that is that, guys. That is this question to get your 4 marks. I know it took long, but I just wanted to take my time here.